with the previous experience that we have got, with the mindset that we have already built, use that data and then start predicting the new version. Machine learning system is basically based on the mathematics and statistical model which will try to create and predict unknown values. I do not know the values, so without the known variables, when you are pressing into it, you will start getting into unsupervised. Good morning and welcome to the first session, Chapter 2, Unit 1, third semester B.Ca, Artificial Intelligence, where we're going to speak about machine learning. Now, machine learning is a very, very interesting part of artificial intelligence. Why? Because it's going to be a model which is very, very similar to the computer software that is used to recognize the patterns, behaviors based on the previous experience or data. Which means to say that you're now going to make the machine work and behave like a human being. So now the concept here is that you are trying to go with the previous experience. You know that there are certain patterns, there are certain behaviors, there are certain models. Using that, can I make the machine enact exactly like the human being? So now the learning algorithm will try to discover pattern within the training data. It outputs an machine learning model which captures the pattern and predicts the new data. So what we try to do is that with the previous experience that we have got, with the mindset that we have already built, use that data and then start predicting the new version. So we know that, for example, in a cricket match, in a power play, let's say from the first over to that of the fifth over, the number of runs that can be scored by a batsman is anywhere between 50 to 60 runs. So automatically, now keeping that data in mind, in the next power play also we can predict that the run rate per over can be anywhere between 8 runs to 10 runs per over. Now this is a very, very simple calculation which I'm giving to you as an example. But then when we are going to do complex data prediction, definitely you need a machine learning model which will try to help you and come across a better prediction levels altogether. So definitely using ML, we can probably predict onto the meteorology side whether the rain forecast or it's going to be windy, whatever kind of factors and data can be figured in, and we can get better predictions. Followed by, these models represent as a mathematical function that requests in form of input and makes prediction on the input data and provides an output. So definitely, again, we are going to rely back on the mathematical function. This is not going to be a magic at any point of time. So definitely, computer is trying to build in some mathematical function, use that function, use that logic, and then start predicting the output. Followed by which, now the machine learning exactly is a technique which uses mathematics and statistics. So this is exactly where the myth is completely broken. Many people think that machine learning itself is like one robotic, it's like one rocket science. It uses its own genius mindset altogether. But let me be very clear on this part. Machine learning system is basically based on the mathematics and statistical model which will try to create and predict unknown values. So there is some functionality that is used. It might be a regression model, it might be a correlation model, it might be any of the statistical model that is being programmed that's going to come in here and give out the data. Now, types of machine learning, we start with supervised machine learning, we start with unsupervised. Then we would start getting into the different factors which will make us learn how these things are working. Now, in a supervised machine learning, this approach starts with a data set known as label values. Now, whenever I'm going to use this word label values, that means the values are predicted. They are going to be having a particular set of values. Here the model is able to be predicted with the help of a data set. Data for which we already know the target answer is known as labeled data set. So here we already know the values, so you don't have to worry at all. It is already inbuilt, it is set. Now, two types of supervised machine learning task will include the relationship between two or more variables, where you will start seeing the regression model coming into picture. Now, in this, whenever we are using a regression in machine learning, it's basically used to understand the relationship between variables and the desired outcome. So, for example, you are going to use a regression model to understand the performance of a student. So, his performance versus the test outcome, his hard work versus that of the output. All these kind of models can come into the picture. Now, you can even use an automobile sales company trying to understand the regression model in terms of sales versus performance, in terms of the brand value versus that of performance. So all these things can be fit into a regression model altogether. Now, this regression is which will include the features of both the values of the label. Now, we will start training the machine using this known values, try to build a system that will again and again try to understand the known set data. Using that, we will start predicting the near similar value. So, which means to say that every sequence, every situation, you will be trying to get some known data set. Using that known data set, we will approach the unknown value. So, if you know the sales, then probably you can start predicting the next year prediction. So, if you know how's the performance of the engine, then you would be able to predict the output that's in terms of power. So, what is going on here is that using a known value, you are going to predict the unknown or the X value. Now, classification. It is a form of machine learning that's used to predict category, class, or which item it belongs to. The machine learning technique can be applied to binary and multi-class. Now, let's bring it with an example here. Let's go to a health clinic, and there you will see that the characteristics of patients are based on age, weight, blood pressure, sugar levels, or probably you are going to use other functions altogether. Now, using all these factors from the blood report, I'm going to come to the conclusion whether the patient is suffering from diabetes or not. Now, in this, the characteristics of a patient are the features, and the label is the binary classification, which will be either 0 or 1. So let's say that I'm going to use 10 different parameters to understand whether this patient is under the risk of diabetes or not. But the end result, the answer is going to be either yes or no. To get to that answer, I need about 10 parameters. So those 10 parameters are your classifications. Using that classification, you will be arriving at results. So that's exactly where we are using this word called classification in machine learning. Now, the unsupervised method. What is an unsupervised method altogether? Where we are going without the known variables. That's the most important thing. I do not know the values. So without the known variables, when you are pressing into it, you will start getting into unsupervised. No training is given to the machine. Now, this is something which is very, very fantastic. Why? Because I'm not going to train the machine. The machine is going to have unlabeled data and learns itself without any supervision. So it is a self-motivated, self-driven, and self-objective oriented. So means to say that it is able to run the data set by itself. The machine tries to find a pattern in the unlabeled data, and then it takes forward. One type of supervised machine learning task is called as clustering. Now, clustering is very, very important for all of us to know. Why? Because this is the method of dividing the objects into clusters that are similar between them and the dissimilar objects. So automatically what will happen here is that we will start understanding how is this cluster model going to work. Now, for example, let's try to find out customers made similar product purchases. So now when you cluster it in terms of saying the purchases are being similar, similar, the groupism is being similar, we want to find out what is the commonality, the common factor that makes customers buy the same product again and again. Now, what is that common feature? Why people stick to one internet service provider? What is that common feature that people like to go on in terms of going behind a particular brand? So all these things will start coming here in an unsupervised. Why? Because we don't have an exact answer to it. So we are trying to put in here unknown variables, and the unknown variables will be taken up by the system and they will take it forward in terms of predicting the values. Now, what is an Azure Learning Studio? Now, this is an Azure Machine Learning Studio, is a web portal for machine learning solutions. Now, Azure is the software that's bought in by Microsoft. It has a wide range of features and capabilities which will help the scientists to prepare data, train models, and publish predictive services. Now, this automated learning part of the story is that it will automatically try to multiple pre-processing techniques, and it will use all those model algorithms in parallel. What are we exactly trying to do here is that train the models without extensive data science and programming knowledge. So I'm not going to get into that typical programming model. I'm not going to sit and keep on writing lines and lines, code after the code. What I'm trying to do is that use the minimum data and try to get the maximum prediction out of it. Now, the more the parameters you are going to set inside this, that means the prediction levels will also keep changing. So in an automated processing, what we typically tend to do is that we try to hold on to the parameters to the minimum values and ask the system to come up with the maximum prediction. Now, what is an Azure automated thing? For the people with data science and programming background, it actually helps to save time and resource, and it starts doing the calculation by itself by a hyperparameter rating tuning. You can understand this once you are learning that studio factor, and now the operations that you run are called as jobs. Now let's get back to this automated system learning for a while, because when you're talking about this automated running system, this is a fantastic system that will try to run with you. That will try to go ahead and try to understand the parametric functions that we have set all together. So that's why this is very, very important for us, where it is getting into an automated system running process by itself. Now, let's understand the AutoML. First thing is that you have to prepare the data, where you'll identify the features of the data set. Then you will train the model, in which what will happen, you will split the data into two groups, a training and a validation set. Now you will first train the machine learning system and then test the machine with the validation data. You will find out whether the results are same, what we have used in the training and what is the outcome. Evaluate the performance. That's very, very important. You have to check the results whether they are exact in nature. Many a times what will happen here is that you might have got a different set of answer when you are trying to do it in a test data environment. But when you are going to run it in an actual data environment, the results would differ. So that's why we say evaluate the performance, then we will be able to find out where the labels are exactly working. Now we are going to deploy a predictive service here. Now, a deployment of a predictive service is quite interesting for all of us to know. Why? Because whenever you're deploying a predictive service, the actual answer behind it is that you are trying to get into a model which will start telling you the outcome as you start changing the input. Now, the predictive service is the real part of the game. Why? Because everybody wants to know the output as soon as possible. Nobody wants to wait for the output to come in. Earlier days, what used to happen is that we used to sit and write the program code line by line. So there used to be hundreds of lines where you would have written a program to just find out one result. At the end of the day, if there's going to be even a small mistake, again you have to go back, keep correcting, changing, and wait for the output. Now we are not going to do this all together. We have already fitting in that predictive service as an integrated part of this exercise. So as and when you start putting in the data, you will be able to see the output also coming in simultaneously. Followed by The four kinds of compute resources, you're talking about compute instances, development workstation that these data scientists can use, compute clusters where the scalable part of it, on-demand experience processing. For example, let's say Amazon wants to go ahead and expand its delivery operations somewhere in United States or in UK or in China or any other part of the globe. So you need to scale up your operations. At that point of time, your environment should be in such a way that you are able to match the requirements of the organization as well as the customers so that you're able to deliver your products. So that's exactly where this cluster scalability comes into picture, and you are able to deploy as soon as possible. Now, inference clusters are one for predictive services that you are using it for the trained model. Attached compute, now these links are existing Azure Computer Components resources, which are like virtual machine or Azure development cluster. So these are also going to be used. When we talk about this attachment base altogether, these are linked resources. It's already there inbuilt with that. So automatically it will be able to tell you, it will be able to compete and go ahead and tell what are all the resources that are available. So using these things, we would be able to get on to that learning part of the system. So, one time when we are talking about a single shot result, I'm going to talk about instances. Cluster is more on the scalability level where you can expand the flexibility. Inference is like a deployment service for the predictive factor, and the linked-in systems are called your attached systems or attached compute. With this, I come to the end of the machine learning part. I hope and believe that all the facts, figures that we have spoken here would be of a great help to you, both in terms of theory as well as in terms of the practical walk of life. In the upcoming sessions, we would be learning more about artificial intelligence. But until then, stay tuned, stay blessed, and stay enlightened forever. Thank you once again for joining with me today on this wonderful session.